Welcome back to All This Math. This is Professor Parker, and for this lesson, we're going to solve a trigonometric equation. All right, so take a look, check it out. You should write it down in your notebook or on your paper or whatever. We're going to solve this equation. We're going to solve for x. All right, so first take a look at what we have. We got one. Oh, before I do that, I got my Norfolk State sweatshirt on, so shout out to Norfolk State down in Norfolk, Virginia. All right, but let's look at the equation. We got 1/2 secant. This SEC, it stands for secant. It's an abbreviation for the word secant, right? And secant is the inverse of cosine. Cosine is abbreviated COS. You see that more often than secant, right? The more popular trig functions are cosine, sine, and tangent. And then, of course, you got the inverses. You got secant, cosecant, and cotangent. All right, so anyway, this equation is 1/2 times secant of x minus 1 is equal to 0. Now, you should always begin with the end in mind, right? We want to solve for x. We want to know what numerical value of x will make this a true statement, because math is all about the truth, right? We want to establish the truth. So we want to know what number can I replace x with so that when I do the calculation on the left side, everything is going to be equal to 0. All right, and we find the truth. We find a true statement. So the first thing we want to do is we want to get rid of a bunch of stuff, because when you solve an equation, it don't matter what the equation looks like. It don't matter if it's a trig equation, if it's an algebraic, if it's geometric, it doesn't matter. We're trying to isolate the variable. No matter how long the equation is or how small the equation is, we're trying to isolate the variable. So if I'm trying to isolate this x, that means I got to take an account of what do I got to get rid of. So I know I got to get rid of this -1. I got to get rid of this 1/2. And I got to get rid of this secant abbreviation right here. So that way x will be by itself. But it's like an order of operations to how you do it, right? First thing I'm going to get rid of is this -1. I'm going to get rid of this -1 first. Now, the way you get rid of things in an equation, just like in any equation, is you do the opposite operation, right? So the opposite of subtracting 1 is adding 1. So I'm going to do this. +1 on the left side, +1 on the right side. That cancels out. -1 plus 1 is 0. So the -1 is gone. So now we got 1/2 secant of x is equal to 1. All right, so we're getting close. Now I'm going to get rid of this 1/2. All right, I'm going to get rid of the 1/2. Now, how do I get rid of 1/2? I do the opposite operation. Right now, 1/2 is being multiplied by secant of x. So the opposite of multiplication is division. But here's the thing, though, which you might notice. This is a fraction. The opposite of, well, let me say this. Dividing is the opposite of multiplication. So I could say, well, we need to divide by 1/2, which is correct. But what do you actually do when you divide a fraction by another fraction? You actually multiply by the reciprocal of the second fraction. So if I'm trying to divide by 1/2, that's the same thing as multiplying by 2. That's what I end up doing anyway. I end up multiplying by 2 because 2 is the reciprocal of 1/2. And whenever you divide fractions, you do the keep, change, flip thing. I mean, that's probably the most popular way to divide fractions. You don't got to do it that way, but that's probably the most popular. So when we say flip, we mean you take the reciprocal of the second fraction in the division problem. So if I was trying to do 1/2 divided by 1/2, I would take the reciprocal of the second 1/2, which will be 2/1, which is the same thing as 2. So dividing by 1/2 is the same thing as 2. That's what I'm trying to get you to understand, in case you don't already understand it. Dividing by 1/2 is the same thing as multiplying by 2. So we can look at it like this. We can say times 2. And if I do it on the left side of the equation, I got to also do it on the right side of the equation. So now I'm doing 1 times 2. So these 2's are going to cancel out, leaving me with just secant x. Now, in case you're wondering what happened to the 1, ask yourself this. What's 1 times secant x? It's just secant x. So that 1, you don't even need that. Then over here, we got 1 times 2, which is 2, right? Now, when we get to this part is where we want to convert this secant into a cosine. And this is one way to do it. You don't have to do this, but I prefer to work in terms of cosine, sine, or tangent. And since I know that secant is the inverse of cosine, I can flip this and change this into 1 over cosine of x. See, secant x is the same thing as 1 over cosine of x. And that's something you just have to memorize. You got to just memorize the trig equivalents, right? So I'm trying to solve for x, and I got a fraction over here, and I got an integer over here. But I can change this to a fraction because what I can do is I'm trying to get x by itself. So what I'm going to do is, well, really what I'm trying to do is get cosine x by itself. But now cosine x is in the denominator. So I'm trying to get cosine x by itself now, right? So I'm going to treat this like a fraction. Boom. And I'm doing this the long way. I'm doing this the long way just so you can see it step by step, right? I'm going to cross multiply. So I got cosine x times 2. I'm going to put the 2 in front of the cosine x, right? Don't put the 2 after the cosine x because that means it will be part of the angle. And it's not part of the angle. The angle is x, all right? So I got 2 times cosine of x is equal to the product of this diagonal, which is 1, all right? So now I'm going to get rid of this 2, all right? Now the opposite of multiplying by 2 is dividing by 2, all right? So dividing by 2. Now if we was dividing by a fraction, we would divide by the reciprocal. But 2 is not a fraction, so we're not dividing by the reciprocal. We just dividing by the same thing, which is 2. So I could do divide by 2, divide by 2. These 2's cancel out. That leaves me with cosine of x is equal to 1/2. So I got cosine of x is equal to 1/2, right? Cosine of x is equal to 1/2. So now I'm trying to get x by itself. So what do I got to get rid of? I got to get rid of this cosine. Got to get rid of this cosine. So we kind of can do something which is we take the inverse cosine to get rid of cosine, right? So it would look like this if we technically wrote it out. Cosine inverse of cosine of x is equal to the cosine of an inverse of 1/2, right? So what happens is this cosine inverse and this cosine will cancel out because they're inverses of each other. And then I'm gonna slide up here with my work. So x is what's left on the left-hand side. On the right-hand side, this is the inverse cosine of 1/2. So what we're looking for is what angle has a cosine value of 1/2? What angle has a cosine value of 1/2? And another thing, there's something I left out in the beginning. We're trying to solve for x in the interval from 0 to 2 pi. Now, what that means is that if we deal with the unit circle, right, which I'm gonna grab a piece of paper that has a picture of the unit circle on it. I don't really have space to draw a unit circle right here, but because I'm gonna do some other work right here. Matter of fact, you go to unit circle drawing right here, right? And what I suggest is if you don't already have a copy of the unit circle in your notebook and in your possession, just go on the internet and just look up, just Google unit circle. And then just a whole bunch of unit circles will come up, print one of them out. They're in your textbook also. And really, you should memorize these. Like now, I don't have all these values memorized. I should. I forget them over time. It comes back to me, but then I forget them again. If you don't use it, you lose it type situation, right? But we looking for the angle that has a cosine of 1/2, but within this region, right? Within this interval from 0 is right here, all the way around to 2 pi. 0 and 2 pi, the same thing. So meaning all the angles that have a cosine value of 1/2. Now, if you notice, all these angles that are shown on here, you probably can't see this, right? But all the angles that are shown on here, right? They have coordinates. They got an x value and a y value, right? X value and y value. So when you get to this part of the problem, what you got to do is if you're looking for cosine corresponds to the x value of these coordinates. If you was doing a problem dealing with sine corresponds to the y value of these coordinates. Tangent, right? Tangent is just the y value divided by the x value, right? And there's actually another trig, a table of trig ratios, a trigonometric ratio table that you can also download that's online available, that has, sine, cosine, tangent, secant, cosecant, cotangent for the most popular angles as well. All right, so you won't have to do the calculations necessarily. But I'm looking for the angle who has a cosine of 1/2. So I look at this unit circle and I see that I'm dealing with pi over 3. So that means that x is equal to pi over 3, right? And pi over 3 is in the first quadrant because pi over 3, which is the same thing as 60 degrees, right? And so that's got an x value of 1/2. So that means that's got a cosine of 1/2, right? But then if I go to the second quadrant, I see a point that's got a x value of negative 1/2. So that's not going to work because I'm looking for positive 1/2. I need positive 1/2, right? So then for positive 1/2, the third quadrant, it's not going to work because 4 pi over 3 has an x value of negative 1/2 again. But then when I go to the fourth quadrant, 5 pi over 3 has an x value of 1/2. So these are going to be my two values, my two solutions for this. So this actually has two solutions. So that means that 1/2 times the secant of pi over 3 minus 1 is equal to 0. And 1/2 times the secant of 5 pi over 3 minus 1 is also equal to 0. All right. And we could also check our work. I mean, we could prove it, right? So let's try to prove that pi over 3 is correct. So we're going to check, and I'm going to do 1/2 times the secant of pi over 3 minus 1 is equal to 0. Now, I want to know if this is a true statement, right? First thing I'm going to do is I'm going to find the secant of pi over 3. And the secant of pi over 3 is going to be, well, secant is the inverse of cosine. So if I can find the cosine of pi over 3, which is 1/2, the cosine of pi over 3, according to this unit circle, according to the unit circle rather, right? Which you can download off the internet, right? If it's not already in your textbook. The cosine of pi over 3 is 1/2, according to the coordinates on the unit circle. All right. So secant is just the inverse of whatever the cosine is. So we take the inverse or the reciprocal of 1/2, which is 2. So that means that this whole thing is equal to 2. The secant of pi over 3 is 2. So now I'm doing 1/2 times 2 minus 1 is equal to 0. Now the question is that a true statement? 1/2 times 2 is 1, and 1 minus 1 is 0. So that's true. So that means pi over 3 is good. That's a good answer. Now let's check 5 pi over 3. Now for 5 pi over 3, we're going to do the same thing. 1/2 times secant of 5 pi over 3 minus 1 equals 0. I want to know if that's a true statement. So I'm going to look for 5 pi over 3 on my unit circle. I find it right down there in the fourth quadrant. 5 pi over 3. That's the same thing as 300 degrees, right? It's in the fourth quadrant. So 5 pi over 3. The inverse of secant is cosine. So the cosine of 5 pi over 3 is also 1/2. So the secant of that, which is the inverse or the reciprocal, is going to be 2. The reciprocal of 1/2 is 2. The inverse of 1/2 is 2, right? The multiplicative inverse, not the additive, because that just means the additive inverse is just when you switch the sign from positive to negative. But we're not doing that right here. So again, we got positive 2 for this. So that's why we know that this is going to be a true statement. So 1/2 times 2 is 1, and 1 minus 1 is 0. So these are good answers. These are both good answers. So these are our solutions. Pi over 3 and 5 pi over 3. All right. These are the values. These are the angles, rather, the angle measures that have a cosine value of 1/2. The only two angles on the unit circle that have a cosine value of 1/2, right? You can't use the ones that have a cosine value of negative 1/2. All right. If this was plus or minus 1/2, right, then it would be that. But that's not what it is. We're only looking for the positive value, the positive 1/2s, not the negative 1/2s. All right. So, but these are some of the things you have to do to solve for x, to get x by itself. Well, to get the cosine of x, or get the trig function with x in it by itself, and then you get rid of the trig function in order to isolate the x. See how we went from here up to here, right? That's what we did. All right, and then you should check your work. Check your work just to make sure. All right, now I've shown you how to do this, and every problem does not look like this, but a lot of them do look like this. So now this is a guide. Now you got to go find some practice problems and go get some practice. Once you go get the practice, that's how you really learn. All right, use this video as a guide and then go get some practice. All right, peace.